So I wanted to talk a little bit about my redefine project, redefining instruction project. My project is centering around how I deliver lectures, and it's actually evolving into something quite different than what I expected. But I do want to describe the phases that I've gone through. The first phase, discover and empathize, I used a flip grid and asked my students to give me ideas for what they thought might be a better way or a more engaging way to deliver lectures. And begrudgingly, I got most of them to contribute ideas, so that was good. And then for the define and interpret phase, I took what I felt were the most meaningful and engaging ideas and put them on post-its around the room and had the students dot vote. So they posted 3 dots on their favorite idea, 2 dots on their next favorite idea, and then 1 dot on their least favorite of the 3. So let's look at those. So this is my sample flip grid so that you can see what I want you to do. I want you to tell me in a video what you are suggesting to improve the delivery of lectures.
You should put more diagrams in your lectures.
I think we should have guided notes, and they should be worth about 5 to 10 points, because it'll get us more engaged, to pay attention, and give us more initiative.
Use this to make diagrams.
So I wanted to take a minute to explain what this is when my student says use this to make diagrams. I don't have a smart board in my classroom. I have a regular old whiteboard that I attach with suction cups, that device he has in his hand, which is called a Mimeo. And basically what that does is it converts a standard whiteboard into a smart board like interactive whiteboard. So he's suggesting that normally when I am recording my lectures, if I need to stop and explain something, because my lectures are just basically a PowerPoint with my voice, recorded over it. So if I need to get up and draw on the whiteboard or explain something that isn't in the PowerPoint, I pause the PowerPoint and the recording of that lecture, and then I do my explanation. I many times will have an example of something that we're talking about in the curriculum, or I may draw something on the board to further explain something. But during that time, I don't record that part of the lecture. And so what Rebel's suggesting is that I do continue recording during that time of explanation. Makes a lot of sense to me, because if they're not there that day, or or especially my students who are only viewing lectures at home, they need to get that content. So he's suggesting that I use the interactive whiteboard to do the drawings, and so I can do that either on my desktop, my laptop, and it will show up on the whiteboard, or I can get up and, using a camera, record myself doing the diagrams or the explanations or an example of a piece of equipment or a part or something like that. So that's what he's suggesting.
Maybe you should make like a Kahoot over the lecture for extra credit afterwards.
I think you should have interactive notes during the lecture.
I think we should have like guided notes for during the lecture so it's easier to like take notes about the lecture.
We could do more activities like the rap that we did so that we are able to better understand and interact with our environment.
So I feel like there's another explanation required here. My student Mason talks about a rap that they did in class. And it's just a tool that I use to help them memorize a certain order of colors. It's the color code for the TIA EIA 568A and 568B wiring standard. And they need to memorize that so that they can terminate network cables more quickly and correctly. And so over the years, I have decided that to make this more exciting, I divide the classes up into small groups, and they then have to come up with a rap that incorporates the color code, and this definitely helps them to memorize it. And so I think I'm going to put a little sample in here.
We're bent to HDMI. Y'all stand up. Yeah, you'll need to sit down too after fainting from our awesomeness.
Okay, you're going to run through it twice.
White, orange, orange, white, green, blue, green, white, brown, brown. White, orange, orange, white, green, blue, green, white, brown, brown.
I think there should be guided notes of the lecture.
Assign mastery checks at the end of the chapter.
I say we split up the lectures into multiple videos that we watch before we use the information.
I believe the way to fix lectures is to basically disregard them entirely. We should just carry on with activities and, well, more hands-on stuff than just learning through words and ear to ear. So, like, more stuff can, like, with stripping and wiring and more, like, into internal parts of the computer and stuff. That's what I feel. Well, bye.
We can split up the chapter in different parts.
So I'd like to see the lectures be divided up into like 2 sections if they're longer than more than like 30 to 35 minutes. So it's a little bit easier to watch from time to time. And like when you're talking about the figures, show them what you're like, show us what you're talking about. It'd make a lot more sense if you do that.
I think we should have questions inside the lecture, keeping us engaged. It'd be really cool, okay? It's an idea. Just take it into consideration, okay? Bye.
I think that playing some type of review game might help after watching some lectures.
I feel like the lectures should definitely be split up into multiple parts just because I feel like that big time, like if say if the hours, like the lecture's like an hour and 30 minutes, I feel like that time definitely scares away most people. So if I feel like if that time is like definitely dimmed down to where like it's split up in like 3 parts where it's like 20, 30 minutes or so, and I feel like, oh hey, I can watch this here, I feel like it definitely just like organizes time for us better.
So I'm gonna go off what Damien was saying and about guided notes. It does help a lot. And then also, we should have periods in between lectures. Maybe do something hands-on instead of having a really, really long lecture and just sit there and take notes.
Split the lectures into a series of smaller videos.
So then the next part of the project was dot voting, and I came up with the 3 ideas that I thought were the most reasonable and helpful, and so I put them on big post-its around the room, and then the students were given 6 dots, stickers, to vote, and they were told to put 3 dots on their favorite idea, 2 dots on their second favorite idea, and 1 dot on their least favorite idea for implementation. And so here you'll see the first idea was to use the interactive whiteboard to enhance lectures, and what I did with this one was I kind of combined a couple of ideas into one, and there's the votes on that one. And then the second idea was to split up the lecture into smaller parts, and you'll see the votes on that one. And then the last one was to implement more activities like the RAP for memorization. I have revisited the defining and interpreting phase of the redesign project this week. Because as I was going through the presentation on learning by design, I realized that I do have some content areas that, well, back up. What I'm looking at redesigning are my lectures. I have quite a bit of content in my curricula that require explanation and not necessarily traditional lectures, but that's how I have been doing this for a while now. And in fact, I do record my lectures so that if a student is absent, then I post that lecture to YouTube and they can catch up. Or if on the off chance a student, I don't know, falls asleep during a lecture, then they can go back and see what they missed. Also, if you've been following along in my other posts, my advanced class is a Cisco networking class, and those students are not required to attend class every day. So their lectures, the only way they do get those lectures is through YouTube, where I post them. So when I decided that I wanted to look at redesigning these lectures because they can get very long, I solicited input from my students, and they didn't really like it very much, but they did end up doing some little flip grids for me and recording their suggestions. Well, some of their suggestions I thought, that's just because he doesn't like lectures. One such suggestion was, let's just eliminate lectures altogether and do more hands-on stuff. I get that. And at first, my reaction was, yeah, we can't just do hands-on stuff when we're covering things like theory. So I just wrote that suggestion off. But as I was going through the Learning by Design presentation this week, I realized there are definitely topics, in fact topics that I, right now, don't use lectures for because they don't lend themselves well to lectures. They lend themselves well to explanation, in-person, group discussion, demo, practice, that kind of thing. And one topic that I decided, this is the reason why I went back to the defining and interpreting phase, is a really good example of this. and it's the topic of subnetting networks, subnetting IP version 4 networks. So you can see on the screen here that I went ahead and used the Learning by Design placemat and threw out some thoughts. I think I used it correctly, but maybe not to its optimal use. But I came up with some, well, it's just kind of like a brainstorming tool is the way I saw it. So what I want to do is explain to you the beginning part of my subnetting lesson with my students. These are my advanced students, so they actually have to show up for class when we're covering subnetting. But the beginning part is actually making a correlation, helping them to make the correlation between our traditional decimal numbering system that we use every day and we have since we were babies, because we have 10 digits, and then correlating that to other numbering systems. And the numbering system that is a part of subnetting is the numbering system that's used for IP version 4 addresses, and that is binary. So what I'm going to show you is how I start out this lesson. There's a whole lot more to subnetting than just binary, but this is a very early stage of this lesson, and it's absolutely necessary that they understand binary before we move forward. So here is how I start this out. We talk about positional notation and exponents and how the value of a digit in a number, in any numbering system that uses positional notation, which I think they all do, that the value of that digit varies based on its position in the number. And so I explain when we're talking numbers in decimal what we really are talking about, and that is something like this. And if we're talking about the number 2018, you can see here I have the 2018, and those digits are in their position according to that number. So I explained that what we are actually doing is we're taking 2 times 10 to the third plus 0 times 10 squared plus 1 times 10 to the first plus 8 times 10 to the 0, and we end up with 2018. So my goal is to help them then be able to transfer that existing knowledge to a different numbering system like binary. So I explained the differences between the two numbering systems, and that is that we have a different base, or radix. Decimal is a base 10, binary is base 2, and that means that we have 10 digits to work with in decimal, and we only have 2 digits to work with in binary. And then the value of the columns, or the positions of the numbers, varies because now we're talking about a base of 2 instead of a base of 10, multiples of 2 instead of multiples of 10, and so on. And then the final step of that transferring or correlating their existing knowledge to something new is writing out a binary number and placing the digits in their corresponding positions and explaining that the value of each of those digits is different because of its position in the number, and how we can convert now this binary number of 1100110 to a decimal number by doing the same thing that I showed them with the 2018. Taking 1 times 2 to the 6th and adding it to 1 times 2 to the 5th, and adding that to 0 times 2 to the 4th, and so on. And so what this tells them is that I can take this binary number, 1100110, and I can determine its decimal equivalent by doing just some very simple multiplication and addition. And so here is where I'm at. I am in the process of determining which direction to take this redesign project. Should I continue on working on the ideas that my students suggested in the Flipgrid and then voted on with the dot voting? Or should I look at ways of enhancing the lessons that I already don't use lectures for and try to incorporate some technology in those lessons that would enhance those lessons, or a combination of the two. So that's where I'm at right now.